Hello, my name's Mike Taulty and I work at Microsoft in the UK. And this is one of a number of videos around a technology called Prism, sometimes known as the Composite Application Guidance. This comes from the Microsoft Patterns and Practices team and largely targets building Silverlight and WPF applications. But you can use some of the techniques and the pieces delivered outside of those spaces. So you kind of get two things with Prism. You get some documentation and you get some libraries in the form of source code that you can build up for WPF or Silverlight. And as I say, you don't have to use these inside of those kinds of applications, but some of the technologies in Prism are specific for UI work with these two technologies. Prism has a friend called Unity, which is another framework, and we'll talk about that as well in these videos. And in terms of finding these things, if you want to find Prism and so on, if you just pop to a search engine, type in Prism and Codeplex and you'll find Prism. If you want to find Unity, type in Unity and Codeplex and you'll find Unity. If you want to find these videos, you can go to channel9msdn.com/niners/mtaulty, that's me, and I'll put these videos on this site here. If you want to find me, you can go to mtaulty.com, that's my blog, and you'll find it there. If you want to find me on Twitter, you can go to twitter.com/mtaulty and you can find me on there as well. And if you want to find me on email, I'm just mtaulty@microsoft.com. Okay, in this third video around Prism, what I'd like to do is take the code that we produced in video 2, which started off life in video 1, and move that on a little bit further. So if you haven't seen either of those two videos, it's probably worth having a look at those first. At the end of video 2, we had code that was using Unity containers in order to do a dependency injection on a set of dependent services that we had. Specifically, I think we'd written services called something like iInput service, iOutput service, we'd written iCalculator, and something like iInput parsing service. Not so sure on the name of that one, but something like that. And all of this was based around a simple console example. We still haven't got to a Silverlight application, but around a simple sort of console example just to illustrate some of the concepts here. We started to talk at the end of that video around the idea of moving what we had towards a more sort of modular solution. And specifically, I think I talked about a few different things. One was about being able to have a list or a catalog or a set of modules that make up the application. And those modules may well be dependent on other modules. So you'd want to be able to record that fact so that a system that loads these modules knows in which order they go together. Because when we talked about what we'd done so far, we said there was a potential problem in trying to figure out in what order things could actually be instantiated. So we wanted that. We also wanted the idea that modules could be flexibly loaded. So the idea that they might be loaded from, say, the file system, from the web, whatever it might be, maybe from a Zap, whatever it might be, but not just the standard .NET resolution rules. We could affect the way in which modules were loaded and say, hey, load some modules from that folder on the disk over there and then this folder on the disk over here, or whatever it might be. And also flexibly in the sense of doing delay loading, i.e. only load on demand. The other thing we wanted to be able to do was around the idea of modules being able to initialize themselves. So if we're going to flexibly and dynamically load these modules, we need a way of letting a module know that it has just been loaded, and so we can do that as well and take a look at that. And so we'll take a look here at how we can use the functionality for modularity that the Prism framework gives us just out of the box, and we'll move our code around from how it was at the end of video 2 into a more modular system as sort of defined by Prism, and we'll see how that gives us a set of cooperating modules, really, where modules can come along, be initialized, register types into a system that other modules can then come along later on and use. And that still really relies on the idea of having some kind of inversion of control container that we're using Unity for, but we're just taking that a step further with this idea of modularity. Okay, so let's get started and pop back into Visual Studio. Okay, so when we last left our project, what we had was an application project, which is an executable. In there we are using, let me just make this hide for you. In there we're using a Unity container we configure it through a configuration file, and then we ask it to resolve this type iCalculatorREPL loop, and we tell that type to then run. The configuration file is pointing that Unity container to the implementations we have for a number of interfaces, including iCalculatorREPL loop, and then those interfaces are implemented in separate projects. Oops, I've just broken my implementation. In separate projects. And so, for instance, the calculator library contains the implementation we have at the moment for iCalculatorREPL loop, which is based upon a bunch of services: calculator input service, input parser service, and we also have the possibility of registering multiple output services, and we use the service locator interface in order to get all the instances of that particular service. So this is kind of where we left the code in the previous video. So what I want to do is move to a number of modules, a number of Prism modules for this code, and looking at it as it stands right now, my guess is that what I would want is a module for the input and output functionality, a module for the calculator library, a module for the calculator command parsing library. So this is the functionality that knows how to basically take a string and turn it into a command type just for our calculator. So it's very simple functionality. So that would be 1, 2, 3 modules. And my thought is that I'll also like another module which is kind of the main module. So instead of this code having to be explicitly embedded here to do this work, I'd like to move that out into a main module as well and have that load as a module too, just to try and illustrate some idea of dependency really. Okay, so let's work at that. Let's go and build our first module. So what we'll do is we'll start maybe at the bottom down here with the input-output library, and we'll add a new class to this. Let's add a class. I'll call it the input-output library module or something like that. Okay, so let's just add a class. I'll call it input-output module. That'll do. Let's just call it that. There we go. So there's our class. I'll make it public. And I'm going to implement an interface on this type that comes from Prism. So we'll just add a reference. Let's go out to C, Program Files, Prism, which is where I've installed Prism. And we'll just find a library. Let's just grab the composite library there. I want an interface called iModule. Let's bring in the namespace for that and let's implement that. You'll see that iModule is very simple in that you just get called to say, hey, initialize your module. So that's a pretty simple interface to understand. And I'll also want in this module to be able to register some types with the Unity container, or at least whatever container is in use. So I'm going to add a constructor here, and in that constructor I want to take an iService, or rather I want to take an iUnity container. Let me just make sure we've got the reference to support that. Now if you watched the previous video you think this was quite interesting. Let me just pop up and find my library whilst I'm thinking about that. Let's just pop in the lib folder, desktop, Unity. Okay, great. So let's just do this first and we'll talk about it. So we'll take a container here and I'll just keep that in a member variable, iUnity container, and we'll just store that off here by saying this.container equals container. Great. So if you watched the previous video you'd have seen that we abstracted ourselves from iUnity container using iService locator. And yet there isn't an equivalent if you want to register services. So there is if you just want to resolve services, but there isn't, as far as I know, an equivalent abstraction layer for if you want to register services. It's up to you as to whether you might want to build such a thing, but think about that at the point where you're working with this. If you've abstracted your way away from Unity at the point where you're resolving, it might also be nice to do that for registration as well. But I don't think there's one contained in Prism that abstracts you from registration, which is why I'm taking iUnity container here and not iService locator that we talked about in video 2. Okay, so at the time of initialization, what this library wants to do is I'm going to register types with the container. So we'll register a type, input service, and the type there is console input service. That's that guy. Let me just make sure we got that type name in here. And then we're going to register another type. That's going to be iOutput service, and that guy is console output service. But I want to give that a particular name. So I'm going to call that output service 1, something like that. And then I want to register again another type for iOutput service, which is the message box output service, and we'll call that output service 2, something like that. Okay, so when we're initializing, this module will come along and register these 3 types. That's what it makes available to the system, and that's what it's going to register. Let's go and do similar things with our other modules. So let's go over to the Solution Explorer. Let's go to the calculator library and let's add some references to this, which we know we're going to need. So go to C, Program Files, Prism. Let's go out to the library, add a reference to this thing. That's that guy there. And I don't think, yes, we've already got Unity in here. So let's then go to the calculator library and add a calculator module. So let's go and add a new class in here. We'll call it calculator module. And we'll make that a public class, implement iModule, and it's going to be incredibly similar to the other one, so we should really have a base class, I guess. But let's just go ahead and say we'll have an iUnity container in here. We'll have a constructor, and that will take an iUnity container and we'll store it off again. Whoops, not quite. And then at initialization time, this needs to take the container and register a type. It's going to be iCalculator, and it's going to be calculator. Nope, calculator. And we'd also go and register iCalculator REPL loop, which is calculator REPL loop. Okay, so we've registered those things at the time when we're initialized. That's kind of the calculator module. Okay, moving on to our next module, let's go to the calculator command parsing library, and let's make sure it's got the right references. So we'll add a reference to Prism in here, the composite parts of Prism. Let's just go and find that library again. Desktop, composite, bin, debug, composite, and Unity. So let's go and add a reference to, let's go up a few folders, back into the lib folder, desktop, Unity, and Unity. And let's then add a type into this project. We'll add a new class, the calculator command parsing module, calculator command parsing module.c#, and we'll make that implement iModule. We'll make it public. It's going to be an implementation much like the others, so let's take an iUnity container as a field here. We'll call that container. Let's add a constructor. It's going to take iUnity container. Let's save that off in a member field. And at initialization time, let's register the type. So we say container.register type of iCalculator. I can't quite remember what the interface is called, so let's just take a look at it. Let's just have a look at what this is called. Nope, wrong class. It is an interface of iInput parser service, and the type is calculator. The type is called input parser service. Okay, fine. Great, so we've registered that as well if we just resolve that namespace. So we've got 3 modules so far. I feel that I'd like another module, so I'm going to create a new library and put another module into that. We'll see what that module is going to do in just 1 second. Okay, so let's go back to our Solution Explorer and let's add a new library altogether. Let's add a new project. It's going to be a class library. And we'll call this main module library. So we'll add that in. And into that class we'll have a main module. We need to add a few types and references here, so let's rename this first to be main module.c#, and let's add a reference firstly to our own interface project, so that's that guy there. Let's also add a reference to Prism I think in here we're not going to actually register any type, so I really just want the common service location bits. So let me just pop into the lib folder and grab that. Okay, so let's go with that for the minute. I want this to be an I module again. Looks like I don't yet have the reference for that, if that's not right. Ah yes, I need a reference to the Prism bits as well, so let's just add that too. Back in the library, desktop, composite, bin. Okay, great. So now we know what I module is, and let's implement that here again. And we'll throw in another constructor, but I only need to resolve types here. This is going to be my main module, which will actually cause things to happen. So I'll need an I service locator. Let's call that service locator. And I want that to be injected for me at construction time. So let's have that as service locator, and let's just say this dot service equals that one. So we copy it at construction time. At initialization time, what I want to do is get hold of an I calculator REPL loop. That's my interface. Let's call that loop. From the service locator, get me an instance of I calculator REPL loop, and then I'm going to ask that loop to run. So this module I'm being a bit different with. At the time of initialization, this is going to start things actually happening by asking for one of those. And we know that this main module has dependencies then on the other modules. They have to be loaded and initialized by this time here, otherwise things are not going to work. Okay, let me just see if we can still build our code. Okay, so we've added our 4 modules into the 3 existing projects and 1 new project that we just added there. Okay, so we've got those modules that we've built. Let's go and revisit our application code up here, which we haven't seen for a little while, and let's just pop to the program here. And I want to change this so that we're still using a Unity container like we were before, but I'm not going to configure it this way through the configuration file for the moment. But I do still want it to act as an I service locator because we've built code that expects that. So let's just get rid of this other code here for a second. And let me visit the configuration file as well. I want to change the way that works too. So let's just go down here and clear out the configuration file. Okay, great. Now I want to use the modularity pieces of Prism here. So let's add a reference. Let's find the right library. Let's just browse out to see program files, Prism. And let's just make sure we get the library in here. And that's going to allow us to use a type called a module manager. Now, of course, getting used to the idea of working with Unity all the time, what we'd want to do is create an I module manager. Let's call that manager. And we'll get that from our container. So we'll say resolve me a type I module manager. Okay, great. And having resolved that, then we want to say manager.run. So that's going to go ahead and find us an I module manager, and it's going to run it. Now we haven't registered an instance of that thing here, so we should probably go ahead and do that as well. So let's say container.register instance of I module manager, and there is a type called the module manager. Now you'll notice that it depends on a bunch of services. It depends on a module initializer, a module catalog, and a logger facade, something that can do logging. It's a fairly simple interface actually, that one. In fact, the module initializer is also a very simple interface. It's something that knows how to initialize a module, and the logger is something that knows how to log things. But the module manager needs those services, and we're going to have to provide them in order that they can be dependency injected. So in fact, we don't really want to register an instance here. What we want to do is register type. So it's the I module manager is going to be module manager. Okay, great. So we also need, as we just said, a module initializer. So let's say container.register type I module initializer, and there is a type called module initializer. Okay, great. So we've got that registered. We also needed a logger, so let's say container.register type I logger facade. And the simplest one of those we can use here is a text logger, so that's fine as well. I'm not being too fussy here about whether we register types or register instances, but here it makes sense to register an initializer like this, and we'll just kind of proceed that way. So we've registered two of the things that this type needed, but it also needed a module catalog. Now the module catalog is quite an important thing. The module catalog, as the name suggests, is a catalog of modules and the dependencies between them. So one way that you can create one of these things is by explicitly going and creating a module catalog. Make one of those, and then catalog dot add modules, and there's a class called a module info that describes a module. So that's one way of doing this. The other way is that you can get this populated from XAML if you've got some XAML definition. And another way you can do this is by reading all the assemblies in a particular folder. That's another way of doing this. And one more way of doing it is by providing a type called a configuration module catalog, which knows how to read a configuration file. So what we'll do here for the moment is we'll say container dot register type iModule catalog, and the type that we'll use will be a configuration module catalog. And in fact, I suspect that I wouldn't really want to read the configuration more than once, so let's go and create one of those things. Let's call that catalog, make one, and then we'll register an instance rather than a type. So on iModule catalog is going to be catalog. And in fact, I probably don't want more than one logger either, so let's go and make a text logger, and we'll register instance there as well. Okay, so that doesn't feel too bad. So just like we could configure Unity with a configuration file, so we can configure this guy with the configuration file. And once again, what I want to do is paste some configuration into that configuration file rather than try and type it all out. Let's switch to the config file. Okay, so let's paste a bit of configuration in here and then talk about it a little bit. So we're adding a new custom configuration section again. This is for modules as defined by the module configuration section over in the Prism libraries. And then in that modules section we're defining a bunch of modules, and for each one of those things we're giving it a name. So I've got my parsing module, I've got my calculator module, I've got my input-output library, and I've got my main module. And then for each one of those we're defining the assembly file, which assembly on disk represents that module, and then we're defining the type that represents the iModule implementation inside of that assembly. So you can see I've got my calculator command parsing module, I've got my calculator module, my input-output module, and my main module. The last thing that we're doing in here is we're defining that this module here, the main module, is dependent upon the other three modules. So you can see how this is starting to be more structured in the sense that we're putting the definition of which piece of software depends on which other piece of software into this configuration file, or we could do it in code, or we could do it in XAML. But it's a nice way of defining what is dependent on what and what needs loading in which order in order to make that work. So let's go back over to our code here and see if we can run it. And before we run it, let's just reflect on what our application has become. It's become dependent on a Unity container, iService locator. These are nothing to do with any code that we've built. These are all things that we've got from somewhere else. These interfaces to do with modularity that come from Prism and the implementations around some of these things, these guys here. And when we think about our application now up here, we don't even need, as far as I'm aware, a reference to our interfaces library anymore because it doesn't use it. It still is dependent at runtime on a number of modules, but those things are simply defined by this configuration file, and the dependency between them is defined by the configuration file, and the code never even directly interacts with any of those types. We have modules that come along, they register services, and other modules come along later as defined by dependencies and make use of those services. So let's just make sure we've got our output folder in a decent state. So I probably need to make sure that if we go into our bin folder here and the one from down here, let me just copy a few files into the right place. It's going to take me a second because Visual Studio doesn't have these links anymore. So we'll take our main module and we'll copy that and we'll paste it in that bin folder there, and we'll take our input-output library, and we'll copy that and paste it in that bin folder there. Let's just grab that, and we'll take our calculator library, copy it, drop it into the bin folder up here, and we'll take our parsing library and we'll copy that and we'll drop it into the bin folder up here. So hopefully, if I got that right, let's see if we can set some breakpoints. Let's go and see if we can find our various modules. So here's one module. Let's see if this is getting constructed and initialized. Let's go and find our next module, calculator module. Let's see if this is getting constructed and initialized. Let's go find our input-output module, see if it's getting constructed and initialized, and let's go find finally our main module, which we'd expect to be kind of activated, initialized last, and let's see if that is getting constructed and initialized. Let's press F5, see if we got any names wrong in doing all that stuff. Oh, wait a minute, looks like I can't build. I've got some namespaces that are hanging over from previous work that we've done. Let's see if we can build. See if we can press F5. Okay, looks like we failed to find a particular assembly. Let me just see if I can fix that. And I think what I realized I just did was I copied those files into the bin folder and not the debug folder. So let's just fix that. Let's go into Windows Explorer. And let's just take all of these guys and cut them out of here and paste them into the right folder. And let's just make sure that we replace all those files. Great. Okay, let's go back to Visual Studio, close down this source code, press F5 again, see where we get to. Okay, so here we are where our parsing module is being created for us. And it's getting past the Unity container as you would expect. Let's press F5. Here it is initializing itself where it registers its own inputs parsing service. We run along. Here's our calculator module being initialized for us, and once again it gets initialized and it registers the calculator and the REPL loop. We run along. Here's our input-output module being initialized, and it registers the input service for the console, the output service for the console, and the message box service. And then finally, here is our main module being initialized, and it comes along and asks for the instance of iCalculator-REPL loop. So notice that this is quite interesting. This is one module initializing itself by simply requesting a service that has just been registered previously by another module upon which it is dependent. And if you notice about that, it's very loose in the sense that this module hardly knows anything about that implementation. It just knows that there is an interface out there it can use, and because we flagged that as a dependency, it should be available at the point where we run from here. And we should be back to where we've been previously, in that we can now add together a couple of numbers with a couple of output services. But now what we've done is really kind of swung around how this code is built up, such that our main application is really just a point at which a bunch of services come together through module initialization, and that module initialization is just registering types, and then those types have dependencies between them and start to make use of each other in a very loosely coupled fashion. Really, there's very little that these modules know about each other other than that they have certain dependencies. So hopefully you're getting a flavour as to how this is moving along. If you thought that some of this code was a bit lengthy, some of this stuff that we did here, we'll come back and take a look at how we can make that better in follow-on videos. But we'll cut this video at this point and come back in the next video and move along in terms of how we're talking about Prism.